today we are going to listen. This is project manager at OQ Technology, Wadee Khoury. Sorry for mispronunciation. Please go ahead. We'll be very happy to listen about QA technology achievements.
Okay, thanks, Alexei, for the introduction. As you mentioned, unfortunately, Omar had a delayed flight and couldn't join us. So I am presenting instead. And please let me know if you can see my screen.
You do.
Okay, so OQ Technology, let me tell you a little bit about OQ Technology. We are a new space startup founded by Omar in 2016. Our main goal of the startup is, our main goal was to actually provide Internet of Things connectivity, so IoT connectivity from space. And this is a goal, and actually this objective led the progress and the progression of our startup from being a very small company to now we have more than 30 engineers globally. We have offices, our headquarters is in Luxembourg, and we have offices in across the globe. We have in the UAE, in Saudi Arabia, in Rwanda, and in Greece. Basically this is a glimpse into our company, and I will also talk a little bit more through the slides. So we prepared some slides for you, and to lead the presentation. So to talk more about IoT, what is a problem today that terrestrial cellular IoT coverage is only limited to 20%. And the satellite connectivity so far is very expensive, even for the newly LEO options. So again, it's very problematic. From space, it's either very expensive or it's not very feasible because of the very high power requirements, the hardware complexity, also the software complexity, and all of the available solutions are proprietary. This reason is why we are introducing the OQ solution. So at OQ Technology, we have the OQ1 solution, which is a complete package to deliver IoT connectivity from space. And in this regard, we will go deeper through the slides later, but just quickly that OQ now can deliver the full package from user terminals that can collect sensor data to OQ satellites, which can harvest this data and download it to our ground station, and then our ground station network, which can deliver this data to our end customer. So how OQ started? Again, we started in 2016 with our headquarters in Luxembourg. Through the years, we got awarded a lot of contracts from the European Space Agency to develop IoT technology. In 2018, we also got funding from the Luxembourg Space Agency to develop our own satellite mission to kind of exploit the IoT and demonstrate IoT from space. And we launched our Tiger 1 mission in 2019, and we actually demonstrated the feasibility of IoT from satellite to ground. Again, we got awarded several contracts from ESA and other contracts from other institutions. In 2021 and 2022, it was a busy 2 years for OQ. We actually got we launched the Tiger 2 mission, which is it was a very important mission for us because we actually performed real life demos with our partners, Aramco, using the Tiger 2. And we also launched the Tiger 3 mission to have our initial step, basically to build our OQ constellation. In 2022, we got awarded, actually, we managed to collect Series A around 13 millions from Al-Wad, Aramco Ventures and 5G Ventures. And we are very proud of our achievements. You can see it on the right side. We actually can offer a global satellite coverage now, with more satellites have been launched recently in 2023. So 2023 witnessed a very busy year for us. We had the flight demo with MBRC in the UAE. We launched our hosted payload with them. We had our own MaxSat mission, which is an advanced IoT, which carries an advanced IoT payload. And we also launched 3 satellites for our Tiger series, the 4, 5, and 6. And we actually had 2 launches, but they were delayed to early 24. Again, for going back to our achievements, aside from the ability to provide global coverage and to provide the true satellite connectivity, we actually own the intellectual property rights for our own payload SDR, so our own payload hardware and also software, so the IoT stack software for the payload, and also for the user terminal on ground. And everything is developed using the 3GPP standard, so we are compliant and we are open source with the open source standard. So far, we have 8 successful missions in space, and we are very proud of strategic partnerships with Aramco. We have several running commercial contracts with them, and in addition to a lot of other contracts, which I cannot go in detail. And we recently actually signed an MOU with the O2 Telefonica in Germany to provide roaming cellular services in desert and areas where they don't have cellular towers. OQ, we are very proud of our very capable R&D department. We actually have our own research, and we have so far 9 patents filed in Europe and the US. 4 of which were granted, and we also have a lot of claims, and it's ongoing process basically. So more about the Tigers. I don't want to waste a lot of time here because we only have 10 minutes, but the Tiger 1 mission, it was our first satellite in space, and it demonstrated the feasibility of performing IoT in space. And the Tiger 2 mission, we use it to perform real-life demos with our partners Aramco. We deployed our OQ terminal solution, and we collect the data from different sensors. We managed to send the data to our OQ satellite and then to our ground station to process the data further. So now let's go and dig a little bit about non-terrestrial networks. So the 3GPP community actually governs the standardization of the generation, the GE series. And what we know for sure that the narrowband IoT was only introduced in release 13. And release, of course, 15, we witnessed the new radio. But about non-terrestrial networks, actually, release 17 was the first time to have real specifications for describing non-terrestrial networks, which is non-terrestrial meaning that we have connectivity from space. So, however, non-terrestrial network was very important because it opens the door for a lot of use cases. So as you can see, there is a lot of possibilities to use non-terrestrial networks, and basically because it is telecom, we have also interoperability options. So you can have satellites, high aperture vehicles, drones, aircrafts, and everything can be also interoperable. So this is why non-terrestrial networks are very important, and it's still being defined so far. So the release 17 and release 18 and 19 are still defining the specifications and use cases for the NTN. What about the use cases? So we start from describing the classic backhauling. So this is a traditional satellite use case where the satellite is relaying information from a certain ground network to from basically one location to other location. Going to release 17, actually release 17 mostly provided specifications for the transparent payload use case, in which the satellite is being used only as a bent pipe solution. So it takes the information from the user equipment and relaying this information to the gateway, which is connected to the base station and then to the core network. Later, we had seen use cases that involves regenerative payload. So regenerative payload mean that the payload now have processing capabilities on board. So actually, instead of having the base station on ground, we can move the base station, or at least part of it, to the onboard payload, and the payload itself can perform processing. While this seems very interesting, we're still waiting for specifications for this, and it's also requires some onboard processing, so it's more requirements in terms of power and processing capabilities. So what are the upcoming trends or the interesting trends? We have the regenerative payload first. Again, it's very interesting because in this way we actually making the base station closer to the user equipment. So it's actually, we can optimize the latency, and in some case we can actually reduce a loopback from, so there is no need for the satellite to communicate with the ground station and then to the base station, which is on the ground, because we have the base station on board for some cases, which reduces the latency. Again, we need edge computing on board, which requires more power and processing requirements. Another solution is a store and forward operation for the satellite. In this case, the satellite, this use case is very interesting because at some points in the ocean, the satellite cannot just take the information and send it to the ground network because we don't have a ground network in the ocean. This way, we need some store and forward capabilities of the satellite. It's also in deserted areas, and we need this kind of information. So I provided more context to the presentations, so you can later use it as a reference if you need it. Of course, this would require more support from 3GPP to provide the specifications for these use cases. Another interesting use case is GNSS independent operation. Now, the way how it works now with the IoT, that the IoT needs GNSS capabilities inside to determine its location, and we also need some information about the satellite ephemeris to know its location as well. So this requires, or this is causing a lot of time in terms of pre-compensating time of frequency shift. And we also have some times where we have GNSS jamming and spoofing. So this also adds up and causes some basically additional delay and energy consumption on the user terminal side. So having solutions which are GNSS independent are very interesting. And for that, we might need to exploit some uplink and frequency synchronization in some aspects. Again, we have the last one is support of 5G core networks for IoT NTN. So far, the release 17 IoT NTN is only supported by EPC, so the Evolved Packet Core Network, which was inherited from the 4G. So because the new radio, this is a 5G protocol, is actually at some point needs to be integrated with IoT NTN. We need to have support from 5G C for the IoT NTN as well. So this is also upcoming trend in the future releases of the NTN and 3GPP. Going back to our OQ technology and what we do, at the moment we can actually, given that the capabilities we have, we can provide latencies or in terms of acquisition, we can provide 1 to 4 times a day of acquisition. This could serve a number of use cases, including agriculture, utilities, and so on. And the end of this year, we will have something around 30 to 60 minutes of delay because we will have more satellites, and this means more lower latency or lower delay. Again, this will add more use cases to what we can support. And later we will have more and more satellites, and this will even decrease the latency at the end, or the end goal. We want to have less than 1 minute of latency, which is like a near real time, which can actually also allow us to support even more use cases and more sectors. So our OQ technology solution is kind of an aggregator model where we have the satellite, the OQ satellite, and we have the OQ terminal. The OQ terminal is used to aggregate data from different sensors, and it supports a lot of interfaces and send this data to the satellite, which is then interfaced with a ground station, our then 5G core network, and network management system, which can deliver this to the end customer using their computer or mobile phone. This is explained here in more detail. This is a type of sensors. We can have sensors for temperature, CO2, humidity, and other things. And then we have the OQ1 solution. The OQ1 solution now provides support for hybrid connectivity. So it is terrestrial and non-terrestrial connectivity. This way, we will have in some areas where we have terrestrial, we could have interrupted the coverage, uninterrupted. So sensors can send data to our OQ1 solutions, which have a lot of interfaces, and actually more interfaces can be added on request by our customers. Then this data will be sent to the satellite using the 4G and the 5G NB-IoT link, which is then download. I mean, it is sent to our ground station network. For the ground station network, we use a network of our partners' ground station, and we also have our own ground station in Luxembourg, in which we use it to operate our satellites, and we perform some payload operations as well. And then we will have this connected to our terrestrial partners network for the core network, the base station, the dashboards, and everything. Again, the idea that NB-IoT is very good in terms of compared to other protocols for IoT. So the NB-IoT is very good, as you can see here, in terms of latency. It can deliver higher quality of service and message size, more scalability. However, this is a terrestrial NB-IoT, so obviously you can see also the limitations in terms of the range, the coverage, deployment, and the cost efficiency, because we have restrictions in urban area. So by introducing the non-terrestrial NB-IoT, we expect to solve these solutions, solve these problems, or at least part of it, and to make also more cost-effective solutions. So our OQ technology solutions so far are highly scalable. We use the 3GPP standard, and this is very important because when using open standards, we are ensuring the support for long term. We have interoperability between different vendors, and we also have community support, which is very important. We also have very high system bandwidth, high data rate, cheaper module price, and other features which can distinguish us from the competition. The strategy for OQ now is to actually have a chip and module partnerships to provide rapid production or integration for our terminal and hardware. We also want to do this not only for the terminal side, but also for the payload side, because our hardware and software is implemented both on the payload and the user terminal, and having this on chip will actually accelerate the time to market and make production easier and cheaper. And we will have also some cloud accessibility using SIM provisioning. We also own our global spectrum, so we have our own experienced specialists on the spectrum and licensing side, so we can solve this issue as well, so making more competitive prices, and we have our own core network integration with our partners. That's it about now, so I will be happy to answer all of your questions. Thank you.
Thank you so much.
If you have any questions later, please send it to our Chief Innovation Officer on this email on the right side below.
Thank you so much. Please stay on our panel discussion, so I assume there will be some questions for you.
Okay.
Thank you so much.